Hi everyone, welcome to another video. We're continuing on with trigonometry and we're going to revisit an idea we briefly introduced a few videos ago, the idea of the unit circle. Now I've drawn this guy just underneath here, just for a little refresher. This is a way for us to relate the things we've learned from trig to the XY plane, as you can see here. And this also allows us to look at trigonometry outside of just 180 degrees. This is what the essence of this video and what we're going to be doing in future series in maths is going to be all about. Extending past this idea of 180 degrees here to an entire circle around, going up to 360 degrees, and as we'll see later, even bigger values. Now, just for a little refresher on what we talked about in the videos from a while back, say I pick an arbitrary point which has coordinates of x and y, we can express these in terms of trigonometry. Now, if I extend this down, I can see I have a length of y here as given by this value here. So let's actually label that, and we have a vertical height here of y. And we have a length here of x, since this is a horizontal direction now. So we have x and y, and this is a right angle triangle because any horizontal and vertical axes are going to meet at 90 degrees, and we have extended this by some angle theta. Now, if you remember from the previous video, we start at 0 degrees here, where the positive x-axis is, and our angles go out from here. So I've got some angle theta, and as my angle gets bigger, I'm going to get to 90 degrees here. So where my y-axis is here, I have 90 degrees, so if my angle goes up to here. If we keep going along like that, I'm going to eventually get a straight line, the angle along a straight line. So this is 180 degrees. Adding another 90 degrees to that, going down to here, that brings me to 270 degrees. And making a full revolution gets me to 360 degrees. So these, and once we've made a full revolution, we can just start again at 0. Now, what we're going to be doing in this video is redefining some things we talked about before and looking at the identities of whether sine, cos, and tan are positive or negative, sort of thinking about what they're doing in all of these different quadrants. So now we're introducing all 4 quadrants. That's what this video is all about. Now, I have some point x, y here. So looking at this right angle triangle that I've constructed on my grid, let's just draw it down here. I have some height of y, some length here of x, and an angle theta. Now I want to come up with some identities for my sine, cos, and tan. Now my sine of this theta equals to the opposite over the hypotenuse. And now keep in mind, since this is a unit circle, it has a hypotenuse of 1. So this length here is going to be 1. So sine of theta is my opposite over my my opposite over my hypotenuse, so y over 1, which I can also write as y, because any number divided by 1 just gives us the number back. Cos of theta is my adjacent side, x here, over my hypotenuse of 1. So I get x. And my tan theta is going to be just my opposite over my adjacent, so y on x. And I can also write this as, since y is sine theta and x is cos theta, I can write this trig identity here, that I can get tan theta from doing sine theta divided by cos theta. Okay, now let's look at the what all of these trig ratios are doing in these particular quadrants. So in my first quadrant here, I have a positive value of x here and a positive value of y. Because in this quadrant, I have positive x values, positive y values. So if I wanted to take sine, for example, sine theta, let's write it in black. My sine theta, which is my y, is positive. My cos theta, because that's x, that is a positive x value. So cos is positive in this quadrant as well. And tan theta is just the fraction of sine over cos. Two positive numbers give me as a fraction, give me a positive fraction. Now, what about this quadrant over here? Now, let's actually just name these as well. So this is my quadrant 1. Just writing this in Roman numerals here. And I have quadrant 2 here. Now let's look what's happening here. Now, my sine theta, we said corresponds to whatever the y coordinate is. So in this particular quadrant here, my y's are above the x-axis here. So my y is above the origin value of 0. So my sine theta, because that corresponds to y, this is positive. Now let's look at what happens with my cos theta, because now we define my cos theta as whatever the x is doing here. So x on this side of the y-axis is negative. So inside this quadrant here, my x is negative. Therefore, my cos theta is going to be negative. And my tan theta is going to be y over x, or sine theta over cos theta. A positive number over a negative number as a fraction is going to give me a negative number. Because when you divide a positive by a negative, it gives me a negative. Now, let's look at my third quadrant here and see what both of these are doing. Now, in this part here, these are my negative y values. So my sine theta, because that corresponds to my y value as we define down here, my sine theta in quadrant 3 is going to be negative. My cos theta as well, because these are still my negative x values, so everything along this part of the unit circle, its x value is going to be negative. So cos theta is negative also. And interestingly enough, tan theta here, if we think of this as a fraction, y over x, or sine theta over cos theta, I'm in the negative y. Well, y in this quadrant is negative, x in this quadrant is negative. So as a fraction, this will be a negative number over a negative number. When you divide a negative by a negative, you get a positive. So tan theta here is actually going to be positive. And last but not least, we move to quadrant 4 here. And we can see that my sine theta, my y is still, I'm looking at the negative values of y because I am below the origin here. I'm below the x-axis, so my y values are negative. So sine theta is going to be negative. Cos theta, however, now we've moved back into the positive x values. So cos theta here is going to be positive. And finally, tan theta, because that's a fraction of sine over cos, or x over y. The y is negative here, the x is positive. A negative number divided by a positive number, they have different signs. So that'll give me a negative fraction back. So we can see the identities of sine, cos, and tan change for the different quadrants. In this first quadrant, all of them are positive. So I'm going to write a little a here to show that A for all my trig ratios are positive here. In my quadrant 2, only my sine is positive. So I'm going to put an S here, showing that just sine is positive. Over here, my tan is the only positive one. I'm going to put a little t here. And over here in my fourth quadrant, only my cos is positive. So I'm going to put a C. So I can remember this ASTC idea as we go up in quadrants to remember which of the trig ratios is positive where. Now, when I was in school, we had this little thing here with ASTC. Now, because I'm from Sydney, Australia, we have a famous train station called Central Station. The way we remembered this was with this little mnemonic, all stations to Central. Now, depending on where you are in the world, you can, you guys probably have different ones for this, but basically what this means is this tells us that as we go up in ascending order for the quadrants, this tells us which trig ratios are positive. All of them are positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cos in quadrant 4. So now we've gotten an idea basically of how to navigate this unit circle. Now this is a roadmap for when we start looking at some questions from unit circle trig, which we'll be doing in a couple videos time. But this was just to introduce you to sort of the identities of our trig ratios in each of these quadrants. Now in future videos, we're going to talk about the reference angle, introduce what that means, as well as look at some significant values for sine, cos, and tan. And then we're going to go into some practice questions as well. That brings us to the end of the video today. Thank you so much for watching, and I'll see you next time.